Humans had a long time in the past where they didn't. Tino whales were mammals. Back then, people categorized animals very simply. Land creatures were beasts, flying ones were birds, and anything in water was called fish, regardless of size or if it spouted water. For example, in the Bible, the giant fish that swallowed Jonah for 3 days is actually a whale. In other myths, whales are often depicted as sea monsters. No one dared to get close, let alone study them. Even during medieval times, when Catholicism prohibited meat consumption on holidays but allowed fish, whales were served at holiday meals. For thousands of years, no one questioned this practice. Then came Aristotle in the 4th century BC. He was one of the earliest animal biologists who observed and recorded everything himself. He often went to the Aegean Sea with local fishermen, observing marine life caught by them, or dissected fish, dolphins, and small whales at markets. Aristotle noticed that whales were different from other fish. They had no gills but huge lungs, warm blood like humans, and carried full-term fetuses rather than eggs. He documented this in his work On the Parts of Animals, stating that whales, dolphins, and porpoises have lungs instead of gills, are warm-blooded, give birth to live young, and nurse their babies. Despite Aristotle's groundbreaking observations, it took another 2,000 years for people to accept these facts. During medieval Europe, science stagnated and the misconception continued. In the 16th and 17th centuries, with the rise of commercial whaling, whalers saw whales, warm blood, huge lungs, and thick milk daily. Yet, because the milk was too thick and yellowish, they dismissed it as fish eggs rather than milk. This misunderstanding persisted until 1758, when Swedish naturalist Carl Linnaeus made a bold decision in his Systema Naturae. He moved whales from the fish category to mammals based on warm blood, lungs for breathing air, live birth, and lactation. Despite initial skepticism, Linnaeus' logic was unassailable, and eventually science accepted that whales are mammals. But after accepting this fact, scientists faced a new challenge. How do whales nurse their young underwater? This question seems simple but baffled many scientists due to the physical impossibility of it. The main issue is preventing baby whales from ingesting salt water while nursing, since seawater's salinity can severely stress and even kill them. On land, air outside the mouth makes this easy. In water, however, every open mouth faces seawater. Initially, scientists assumed baby whales sucked milk like terrestrial animals, but quickly realized that whales lack lips to create a seal for sucking. Additionally, time was an issue. Baby whales need to surface frequently to breathe, making prolonged nursing impossible. The breakthrough came when scientists examined the mouths of dissected baby whales and discovered their tongues were uniquely shaped to form a funnel-like structure rather than suckling. This led them to rethink their approach entirely. Sure enough, they found that instead of sucking milk, baby whales receive it as a spray from their mother's mammary glands, which are hidden in skin folds on the abdomen. When a calf approaches its mother, the calf uses its head to nudge the mother's abdomen until milk comes out from her nipples. Then the mother whale's special muscles around her mammary glands start contracting, shooting high-pressure milk directly into the calf's mouth. The calf's tongue curls into a tube shape, guiding the milk down its throat and minimizing water intake. Unlike land mammals, this process is quick, usually taking just seconds for the calf to get a drink before surfacing for air. This is why they don't suckle like terrestrial animals. It would be too slow underwater. In the mid-20th century, when captive environments were common, scientists had opportunities to closely study cetacean nursing behaviors. Dr. Olav Aftadal and his team decided to collect samples by hand. They calmed a killer whale with help from trainers, pressed on her breast, expecting milk to slowly drip out. Instead, the high-pressure mechanism sprayed milk all over them like a fire hose. Fortunately, they wore goggles, but no colleague wanted to sit next to them for lunch due to the lingering smell. This discovery was messy and uncomfortable, yet it solved another mystery: why whale milk doesn't disperse in water. Unlike regular milk, whale milk is thick and gel-like, floating without dissolving immediately. Robert Clark collected samples from dead whales to analyze its composition. He found that blue whale milk contains 35 to 50% fat, 10 times more than cow's milk. This high, fat content allows it to maintain shape underwater for precise feeding. Some whalers who lacked fresh food tried using whale milk in tea and soup, describing it as strongly fishy and unpalatable. Yet calves thrive on this nutrient-rich milk, drinking up to 150 to 330 liters daily. The structure of whale milk closely resembles sperm cells chemically, making it easy for the calf's gut to absorb and convert into fat. With water buoyancy supporting their weight, they gain about 90 kilograms per Dalton Y, equivalent to an African elephant's birth weight in just one day. This rapid growth is crucial because newborns face harsh polar waters with little food. Mothers fatten up during summer feeding frenzies, then migrate thousands of miles to tropical waters to give birth and nurse their calves without food for months. They burn their own fat reserves into high-fat milk daily until the calf has enough blubber to survive in cold waters. After nursing, mothers lose a third of their body weight, but it is transferred to their offspring as protective insulation. However, not all whales follow this path. Toothed whales like killer whales have much longer lactation periods, up to 3 years or even 7 for some groups. This is because the biggest challenge isn't cold. It is learning survival skills in complex social structures. In biology, there is a pattern. The more complex an animal's brain is, the longer its childhood lasts. Dolphins and orcas are highly social animals. Their young usually spend several years following their mothers and family members to learn how to use echolocation, hunt, and navigate complex social structures. These skills aren't innate, they need time to develop. During this long nursing period, the milk isn't just food, but a bond that keeps the offspring close for learning. Interestingly, some scientists have observed adult male orcas staying with their mothers well into their 20s, still relying on her to tear apart salmon for them. This prolonged mother-offspring relationship is established during these 3 to 7 years of nursing, giving them enough time to learn and integrate into society. It is a different challenge from racing against time in cold environments. The structure of milk actually correlates with how mothers raise their young. In fact, orca milk is the most viscous. That title goes to the hooded seal living on Arctic ice floes. Their mother's milk contains up to 60 to 65% fat, almost solid. The reason is clear. Hooded seals give birth on precarious floating ice in the North Atlantic and have only 4 days with their pups before they must leave, no matter how ready or unready the pup is. This isn't out of coldness, but survival necessity. Staying longer would deplete her energy reserves, endangering both. So, in those 4 critical days, she packs everything essential into this thick, creamy milk for her offspring. This is evolution's answer to environmental challenges. Now looking back at this scene, you realize that what the whale mother gives isn't just milk, but all she can offer in a harsh oceanic world to nurture new life.